Salutations! We're going to do a little work with some data about a lab with a car that moved along a track because of a hanging weight. Here I have some data that's a sample of what could have come from the lab, and we're going to work with it just to see how you'd turn this stuff into two meaningful graphs that show that when you keep the car's mass the same and change the hanging weight, you get changing accelerations. And then also when you keep the hanging weight the same but you change the car, you get changing accelerations in a different manner. We'll be building two graphs from this data. The first thing that's valuable to do is to come up with the total mass of the system, and that would be the mass of the car and any weights on it, added to the hanging mass. So we could do that here in this column, but instead of doing the math ourselves, we can have Excel do it for us. And all you have to do for that to happen is you select the cell, come up here to your function bar, and tell it you want an equation, which means you start with an equals. And then you say you want this cell, A2, I just left clicked, and then put a plus sign in, and then select the other cell that I want, and it adds them together. So here it has the sum of these two cells, and it's right here in this box. I could type that equation in with a new setup so that it's looking at the third, fourth, and those rows. If I wanted to, I could type each in individually. But it's more efficient for me to hover over this little black box, wait for my cursor to change, then left click and drag, and now Excel did all that work for me. If you look, up here it clicked A5 and B5. It automatically changed to match the proper row, but it kept the calculation the same. This is a useful trick in Excel, and we'll be using it a lot. So, once that's taken care of, now we can take a look at these observed final velocities. For those of you who did this lab, the equipment from Pasco can measure your acceleration, but it pushes the limit of what it's able to do. So many of us chose to go with the observed final velocity. If you do the acceleration, you can ignore this step. But if you have these final velocities and need accelerations, we need to do another calculation. Now, if you remember, as long as your the distance your car traveled was a half of a meter, it would cancel out with the 2 in the equation vf squared is equal to vi squared plus 2ax. And all you'd really have to do is square this final velocity to get an acceleration. So, let's do that now. For this calculated acceleration from trial 1, we can come over here and say what's this final velocity, and we need that to be squared. So add a caret and a 2, and it squares the value for us. There's way more decimals than we need. Excel is not good at sig figs, but don't worry about it. We can take that idea and just pull it on down, and if you look, it follows the same model where it appropriately adapts for what's going on. Now if you take this and you pull it over here, it just did all of these for us, keeping in mind that it adapted automatically to the right column and the right row for whatever we were needing it to do. There's one more type of calculation that's probably worth it for us to do, and that's an average acceleration. So we have these three acceleration values, and we'd like to have an average here. Excel can do more than just mathematical equations. It has plenty of functions that it can understand if you start typing things in, and if you see I've got a little bit typed and it starts to guess at what I want it to do. I want it to do an average, and then I put in a parentheses to say what I want the average of. You can select these three numbers. It shows up as a set with a colon, and that just means that it's from this spot in the range to that spot, but don't worry too much about those details. Close these parentheses to say that's the end of what you want Excel to average. Hit enter, and it just did the average for these cells. Now the same deal applies. We can select those, and we've got all of these averages done, no trouble. So if we want to make a graph, all we have to do is see what it is we'd like to graph. If we want to know the mass of the hanging mass versus the acceleration, we can select this, hold down Control, and then come over here, insert a scatter plot. I love scatter plots. And there we have a graph. There's some tidying up we need to do with labels and those sorts of things, but this is a graph that relates the acceleration of the car to the changing hanging mass. It's worth mentioning that the layouts all come in here, and so the easiest way to do it is with these buttons in the ribbon. The chart title we can change or remove, and so we can say acceleration, oops, acceleration, sorry, of a car of fixed mass with different hanging weights. Oops, it doesn't really need a period. And science titles for graphs can be obnoxiously long. It's okay, the important part is that it's clear. So we have this graph here. We can also put in our axis titles. We can put in a horizontal title below, and down here we can say these look to be our masses, right? So down along that side, those are our masses. And so let's say hanging mass, and then designate our units, kilograms. And then we can put in a vertical axis. I generally like a rotated title. And we could put in over here that this is the acceleration in meters per second, and then just caret 2. We get the idea. There we have a label and a unit. These are sort of obnoxiously long. So one thing that we can do is select these cells, and it might just help to visually clean up the data too. Remove some of these extraneous data points, and it makes it a more reasonable thing to look at in both cases. It's a nice way to manage the data that you see. One of the things we have to do is add a trend line so we can see what the real connection here is, and then you get this sort of a view. Now in here you can set the intercept to 0 if you think that at a 0 hanging mass you should have 0 acceleration, and that seems reasonable. Display the equation and the r squared. Put that in there, and here we've got our equation. This says that the equation of the graph, and the r squared is really a test to see how well that data fits the line that's given, and it can range anywhere from 0 to 1, 1 being a perfect fit. So this is not bad at all. Alright, this legend over here we probably don't need. We could get rid of that if we felt like it. It might help clean up this graph a bit. So with that, the only other graph that I would need would be one that changes the mass of the car and the weights on it and the accelerations, and then I can insert another scatterplot graph, and we can see the trend here. You see it's got almost no labeling right when we make the graph, but that's okay. We can deal with it, play with it, and fix it up so that it's nice and clean. But I'll let you do that on your own. Alright? Hope this helped. Goodbye.